Good afternoon, everyone, and thank you for participating in the Water Resources Impacts of Data Centers and Solar Fields and Tools to Mitigate Those Impacts Lunchtime webinar. I am Stephanie Newmer, a water resources scientist here at the Interstate Commission on the Potomac River Basin, and I will be assisting with the behind-the-scenes coordination of this webinar. Feel free to use the chat option to contact me. In this, I would like to ask each of you to keep yourselves muted and your webcams off. If there are any questions during the presentations, please type them in the chat, and the panelists will then address all questions during the question and answer session at the end of all presentations. This meeting will be recorded and will later be posted on the public ICPRB YouTube page for future viewing. If you experience any technical issues during the webinar, please feel free to ask for assistance in the chat, and I will coordinate with you to resolve them. And with that, I would like to introduce Mike Nardolilli, the Executive Director of the Interstate Commission on the Potomac River Basin.
Thank you very much, Stephanie. I am the Executive Director of what we call ICPRB. I want to stress at the beginning here that ICPRB has no regulatory authority. So this is a pure informational webinar that we are putting on. The event is being held as part of the implementation of the Potomac Basin Comprehensive Water Resources Plan, and funding for this event is through ICPRB's EPA Section 106 grant. The purpose of this event is to encourage dialogue around sustainable water basins resources in the basin. Any reference to commercial or trade names does not indicate an endorsement by ICPRB, the signatories to the compact, or the EPA. And as Stephanie mentioned before, place all questions in the chat box, and we'll get to them as much as we can at the end of the presentations. So we have a great panel here today. I want to well, I guess I want to start off is that the topic is of very much interest in the Potomac River Basin. These are two hot topics. I'll make two brief comments. In Maryland, this session, for example, legislation aimed at settling disputes over the siting of large-scale solar projects on farms or on forests never got out of committee, but it was hotly debated. And on May 2nd, the front page of the Metro section of the Washington Post described the pros and cons of the growth of data centers in Northern Virginia. So it's a very hot topic these days. So this and the panel we have is a panel of experts on all on these two topics. But I want to make a note that the first two presenters will talk about the solar fields issue, and the third will talk about the data centers. So our first panelist is Michael Rolband, who's the director of the Virginia Department of Environmental Quality. He joined DEQ in 2022, a professional engineer, a professional wetland delineator, and a professional wetland scientist emeritus and lead advanced professional. He received his BS in Civil and Environmental Engineering, Masters of Engineering, and Masters of Business Administration from Cornell. And he founded Wetland Studies and Solutions in 1991 and grew that company into a key player on water, wetlands, and stormwater management. I've known Mike for many years. He was the go-to guy for many of my projects involving the Northern Virginia Conservation Trust and Nova Parks. And I must add that he now serves as a commissioner of ICPRB, so he is one of my 18 bosses. Scott Cameron is the director of the Northern Virginia Soil and Water Conservation District. He's the second vice president of the Virginia Association of Soil and Water Conservation Districts. He was appointed by Governor Glenn Youngkin to the Virginia State Water Control Board. And at the national level, Scott is Virginia's alternate to the National Association of Conservation Districts, where he is a member of the Legislative Committee and Invasive Species Subcommittee. Finally, Darrin Geldert is the planning manager for Loudoun Water. He has been with Loudoun Water for 10 years in the planning department. He is focused on master planning, modeling and projections for water, wastewater, and reclaimed water systems. So let's move on to our presentations. Each speaker has 13 minutes. I will give the speaker a 2-minute warning after 11 minutes so that the speaker can finish up their presentation. So our first speaker today is Michael Rolband, who will speak about solar fields. Michael.
Well, thank you very much for inviting me to come here today. If we could just shift to my slides, I'll start talking about utility scale solar implementation in Virginia. Wait till that slide comes up. Okay, so we go to the next slide. The reason I want to talk about this today, besides being invited, is to first of all give everyone a scale perspective of what's happening. The utility scale solar projects in Virginia is probably the largest land use change that's expected or happening since basically the post-World War II era, where we first had a lot of suburban growth. We are projecting a DEQ somewhere by 2045 between 30 and 65 gigawatts of solar power. To put that in perspective, this table gives you the land area that we're seeing right now taken up. We have panel area, and then we have the gross land area. So what happens, there's space between panels. At the densest types of sites are basically 50% covered by panel, 50% open space between the panel rows. But then they often have lots of buffers and lots of areas that they have to avoid for various cultural resource issues or wetland issues or some other type of land use constraint. To put those numbers in perspective, we're talking on the low end 317,000 acres of land, and I've listed some of the Northern Virginia localities to give that a size perspective. If we go to the next slide, I just put it in a map perspective to show you what would happen if the low end is the tan color and the gray end expands it to the high end estimate. So basically, if you just concentrate this in Northern Virginia, where large power usages are occurring, we would cover virtually the entire area with solar fields. So it's a significant land change, even when you spread it across the state. The next slide talks about the issues that we're seeing in Virginia in terms of on the ground. So DEQ regulates, number one, solar projects in terms of anything between up to 150 megawatts. We have a permit by rule approval process that expedites the approval of these facilities. Anything larger that goes to the SCC for approval, but we are one of the key players in terms of providing comments on the environmental impacts. But we also regulate stormwater management and erosion control. Now, these authorities are delegated in many localities to the local government, and we just oversee the programmatic levels, but in some, roughly 100 localities, we do the plan review and inspections as well. And we're seeing a lot of issues. And I want to step back for a second and tell you that I think solar is good. I personally have solar on my old office building. I put solar on my farm. We're roughly net zero. That being said, we have to put it in perspective that when we install these facilities, we need also to follow other regulatory requirements to protect other aspects of the environment. So the first thing that we're seeing is that topsoil is being buried. I mean, what people are doing is they're leveling sites or grading them to a uniform slope, and they're cutting and filling and burying the topsoil and compacting the soil. We'll talk more about what that does. So the second problem we're seeing is a lack of vegetative cover. And these projects are typically designed assuming that there is vegetation on the ground. And that's part of their stormwater management system, as well as part of the erosion control requirements. And we have a regulation that, while some people claim they hadn't heard about it, it's been in place since 1992. So 32 years. It's minimum standard number 1. And we require, when I say we, the Commonwealth of Virginia and every local government that does their own regulations require permanent or temporary soil stabilization. 7 days after final grade for permanent and 14 for temporary. So this issue, this number 2 issue, is that we're finding that people just simply aren't complying with it when they reach the final grade. The next problem we see is the curve numbers. This is a way to calculate how much runoff occurs on a rainfall. And people are using curve numbers that are based on the original soil type, and they're not accounting for compaction or the panel's impervious cover. The next problem we see is a lack of maintenance of all the controls that are required by regulation. We're seeing that they're not, if they are installed, often they're not properly installed. And then we're seeing a disregard for natural drainage divides, which has also been a regulatory requirement for a few decades. So that's what we're seeing on the ground. The next slide is a picture of the classic problem. Panels fully deployed. In this case, this site is operating, creating power, and there's very little, if any, vegetative cover. Yet they reached final grade before the piles were driven to support the panels, let alone putting in the panels. So for several months, this was at final grade. The problem is huge amounts of pollutants are coming from the runoff that occurs. And it's, while people say, oh, we have a stormwater pond or we have a silt fence, that's fine. But at best, those structural controls remove 60% of the suspended particles. And if you have vegetative cover or even just seed and mulch, you're typically getting 90% reduction. And then that 10% goes into the structural controls and 60% is that removed. So you only have about 4% leaving the site. So 4% versus 40% is what we're seeing occur. Next slide is just an assortment of pictures that illustrates, just again, on the left side are some inspections from inspection reports, just classic failure problems. The top right picture is just a picture which I continue to see examples of this in newspapers, where people are proud of their new site and they have an air photo and they put it in the newspaper, and what it shows is a violation. All the panels are fully deployed, bare dirt everywhere. That was supposed to be green by now because it's been several months since they reached that final grade. Bottom is a classic flooding picture. And then the right-hand corner is simply a picture showing why we believe that panels are impervious. Now, we do believe that they're unconnected impervious, so there's a discount, a reduction factor for the extent of runoff, but that initial abstraction, when the rainfall hits the vegetation and the duff layer within the vegetation that's absorbed on those particles and then slowly infiltrated, isn't occurring under those panels. So the first thing we want to talk about in the next slide is the biggest problem in Virginia, and it's minimum standard number 1. So it's number 1. Someone made that decision 30-something years ago to list it as number 1. It's the most important thing, and we're just simply not seeing compliance. We've been told by multiple consultants that the developers simply don't want to do it because it costs money, and they will have to reseed it at least once or twice more later on in the project. So they just want to wait till the end. That's just simply not the way it is, or what's required. It's not good for the water in our Commonwealth. So DEQ is trying to make this the number 1 inspection requirement. And I'm trying to get people to stop working on some of the little nitty-gritty paperwork details and focus on the big picture, which is minimum standard number 1. We've also put out a newsletter article. We've had multiple webinars, and we're trying to communicate to everybody that we need to focus on this. That'll solve a majority of our problems. The next way, though, is to reduce the grading. So if you go to the next slide, something that we put out a couple of years ago when I first came here was we have to rethink how we're building these facilities. And what we're seeing right now is occasionally people try to do a variable foundation that's on the top left corner, where by changing the elevations of the piles on relatively low gradient landform changes, you can get a uniform straight line for these panels. The reason they're trying to do that is in this area, we're using single access trackers. So it's one drive shaft and the panels rotate from east to west. Unlike, say, in more northern climates, you will see a lot of dual access trackers that don't have these problems, but they cost a lot more money. That's why we're not seeing them here. They use them in those areas because they have less sunlight. So instead, what we're seeing mostly in Virginia on the top right is destructive grading, cutting and filling, burying the topsoil, compacting it, then driving the piles to be able to get that uniform shape to have a straight drive shaft. And what that does, of course, is it allows the projects to be installed, but it's not getting that vegetation growing. And then later, when you want to reuse this land for farming, it's not going to be productive farmland. So another alternative is to follow the natural terrain. And what we suggested is use tracking systems that have universal joints in the bearings that can go up and down with the terrain. And in fact, there is a product that's provides that. I didn't know that when I first wrote about this. It's made by Nevada Solar, and they just won the governor's gold award for environmental excellence at BMI, the Environment Virginia, just a few weeks ago. That's out near Winchester. So if you go to the next picture, you'll see a picture of a project that actually follows the terrain. That way, the existing terrain, the existing vegetation could be there in place while they build. And this close-up picture is the founder and the chief operating officer of that company showing an example of one of those bearing joints that I actually took a picture of out in Winchester. So another solution, I'll have to hurry up because I'm almost done with my time, to reduce runoff is, if you go to the next slide, in our new handbook that goes in effect July 1st, but we put it out in a guidance memo roughly a year and a half ago, is to allow the panels to rotate when it rains. And these panel systems already have a weather station with a wind sensor that goes to wind stow, they call it, so they don't act as an airfoil when the winds typically exceed 25 or 30 miles per hour. All we're suggesting or allowing is do the same thing when it rains hard. We've got technical definitions, and then it can rotate, already has the same mechanisms there, and that dramatically reduces the runoff effect by multiple
You have
factors.
two more minutes, Michael.
Okay, and so we allow that. We've talked to some developers of these solar systems, and their estimated cost per weather station is about $2,000. So it's a trivial cost compared to the millions and hundreds of millions sometimes of these projects cost. And they can reduce their stormwater management impacts and the cost of that by millions of dollars. So the next slide talks about another hot topic, which is land conversion from forest and ag. There's a lot of people concerned with people that are clear cutting forests to put solar panels out and taking valuable farmland and converting it to solar fields. This is a picture of potential use of agrophovoltaics. We're using sheep, but there's a limited demand for sheep right now. So there's some issues there. But we have a bill from 2022 by Delegate Weber, House Bill 206, that required DEQ to develop regulations to require mitigation when there's more than 50 acres of contiguous forest impact or 10 acres of prime farmland. Those regs were the result of two SAGs, a large SAG that 90 people or so, and then a smaller technical SAG last summer, about 25 people. Those regs should be introduced in the town hall system by next Wednesday, and that'll go through then the public approval process and public comment. So lastly, to wrap this up, there's a lot, and to go to the last slide. One of the questions is how much runoff really occurs in our more clay type soils that we have in Virginia, and also from the current land practices. So we've given a grant to Virginia Tech and Virginia State University, $3.4 million. They've got an additional 500,000 so far pledged from industry to, number one, measure the water quality and water volume, see what actually is happening, compare that to the current design practices, and improve modeling specific to the situations that we're seeing in Virginia. With that, I'll stop talking. Thank you.
Well, thank you very much, Michael. And we're going to take the questions at the end. So please hold your questions until then. Excuse me. So thank you very much, Commissioner Rolband. I was very interested in the land scale. That's the first time I saw that sort of representation, showing that 687,000 acres would cover much of what we know as Northern Virginia, from the Potomac to the Occoquan. So that was eye-opening. Your detailed examination of the erosion and stormwater issues connected to the solar fields is also very helpful. I, I do believe that many people were not aware of the regulation that you cited, and hopefully that'll make a difference in the future. We at ICPRB are very much interested in seeing the results of the research on the solar runoff that's going to be conducted by Virginia Tech and Virginia State University, particularly as to water quality and the volume from these facilities. So that will be very helpful to us as we plan here at ICPRB. Okay, our next speaker is Scott Cameron, who will also speak about solar fields. Scott?
Good afternoon, everyone. Hopefully you can hear me. So I'm happy to speak with you today. And next slide, please. So I think it's really important to understand that the rate of growth of solar in Northern Virginia is going through the roof. This is data from the State Department of Energy. So we're adding about 5,000 acres per year, based on a linear regression here. Next slide. This is a map, again, from the Virginia Department of Energy on where utility scale solar was in the Commonwealth on January 4th. As you can see, it tends to be concentrated in the Piedmont, especially the south central part of the state and the southeastern part of the state. But we've got some cropping up in Northern Virginia as well. Next slide. Okay, issues. We are losing so far somewhere north of 10,000 acres of forests and about 40,000 acres of farmland in Virginia to utility scale solar. Based on the information from the State Department of Energy, it takes somewhere between 5 and 12 acres of land to have a capacity of 1 megawatt of solar generating capacity. The Virginia Clean Economy Act would have us convert about 320,000 acres to utility scale solar by 2045. But that's a floor. That is a tiny fraction of what we're going to end up seeing, because data centers are typically expressing a strong preference for utility scale solar. I'm sorry, for renewable energy, which is a practical matter, means utility scale solar here in Virginia. Right now, 21% of Virginia's base load demand is from data centers. That's growing at more than 25% a year. And the projection is in a mere 6 years, data centers will be demanding 40% of Dominion Energy's baseload capacity. In order to keep those data centers running, we may be losing up to 1.5 million acres of land, twice, more or less, twice Mike Rolband's worst case estimate. And that's assuming that we do not have nuclear or natural gas to keep those data centers going when the sun's not shining. So here in Virginia, maybe in February or January, we've got 8 hours of sunlight, not 12 hours or 24 hours of sunlight. So we're going to need to have huge battery capacity scattered across the Commonwealth in order to load up those battery centers with solar energy during the daylight hours in winter, so we can discharge that energy at night. So if we have nuclear, we have natural gas, maybe we can cut that down to 750,000 acres. Again, way above the Virginia Clean Economy Act requirements for utility scale solar. Quite concerning is that almost 2/3 of the ag land that's gone into utility scale solar so far is high suitability cropland. So we are losing agricultural productivity in Virginia. At the same time, we can project climate change is going to be reducing agricultural productivity because of drought and competition for scarce water supply in Southern California, Arizona, and Texas. So, we are losing agricultural productivity in other parts of the country while we're deliberately removing agricultural productivity here in Virginia. As Mike indicated, about a year ago, 69% of what were then existing solar facilities were causing some sort of problem. That's a real issue. If 69% of the oil and gas industry or the chemical industry was causing problems in Virginia, there would be a really significant political issue. The solar industry also has to obey the law. And at the same time that we are creating stormwater problems from utility scale solar, our larger municipalities are investing hundreds of millions of dollars, or in the case of Richmond, $1 billion to deal with stormwater management. So we are undercutting the taxpayer investment of Fairfax County, City of Alexandria, Arlington, Richmond, and others by not forcing the solar industry to obey the law. Next slide. Okay, you've already seen this, so I'll move on. Next slide. Okay, so what do? The industry needs to take responsibility for its own supply chain. The Data Center Coalition, based in Northern Virginia, their membership ought to pledge not to buy solar from people who are violating the law. Similarly, the industry ought to take a pledge not to buy solar from facilities that have been clear-cutting forests. So those are two things the industry can do on its own. In terms of what the General Assembly can do, we can fund grants for siting solar in brownfields and old coal mines. Delegate Krizik got a bill passed the General Assembly that the governor signed that would authorize state funding for that. In the next session of the General Assembly, we could pass Krizik's bill for a state personal income tax credit for residential solar. Granted, there's a federal tax credit, but we need to move solar onto rooftops and parking lots and away from prime farmland and forests. Virginia Tech is looking at agrivoltaics. They're doing research on other ways that agriculture can be compatible with utility scale solar. That's a good thing because we need to maintain the agricultural productivity in Virginia that is still our largest industry. Everybody should be commenting on DEQ's HB 206 regulations when they come out, as Mike indicated. Finally, the industry has decided that it wants to stop county governments from exercising their legitimate land use control authority over future utility scale solar development. Happily, 3 bills that would have done that in this last session of the General Assembly died. If those bills are reintroduced next year, they need to die. Again, county governments deserve the right to control land use inside their own borders. Next slide. Okay, rooftop solar could make a difference. Granted, this data from DOE is now 8 years old, but the projection was back then rooftop solar could provide 30%, at least of what at that point in time was Virginia's energy demand. That's not insignificant. Next slide. Similarly, parking lots, according to Time magazine from 2 years ago, nationwide, could provide a third of our electricity needs. Here's a photo of a parking lot in Belgium. Next slide. So think King's Dominion, think Potomac Mills Mall. There are a lot of parking lots in the Commonwealth. The point is, we ought to be, post-solar is good, like Mike, I've got it on my own house, but we should not be destroying our agricultural productivity. We should not be cutting down our forests that we owe under the Chesapeake Bay Agreement. by the way, and we are in the negative under our obligations on the Chesapeake Bay Agreement as a result of losing tens of thousands of acres of forest to utility scale solar. That's it for me. You're muted, Michael.
Thank you. We never got to your 2-minute warning there, Scott. You really went through a lot of information very quickly. I don't know if you want to go back to your 2 slides that are chock full of details and explain a little more. But if you're willing to stop there, we have more time for questions and answers at the end.
I'm happy to stop here.
Okay. So anyway, I did see those two slides that were just chock full of details. I want to ask our staff here is that will those slides be shared? Stephanie or Heidi?
The webinar is being recorded and will be posted in its entirety on our YouTube channel. And I put the link in the chat for the YouTube channel.
Okay, thank you. Yes, slide 4 explains all the issues, and slide 6 had all of your recommendations. I was particularly interested in your discussion of how the development of solar fields impacts Virginia's targets under the current Chesapeake Bay Agreement, and how this will influence the examination of the agreement beyond 2025. Certainly, I think that going back in time, there was not a realization of this explosive growth in solar fields at the time the original Chesapeake Bay Agreement was agreed to. So I'm interested to see how that's going to be feathered into the discussion on as we go past the 2025 deadline and set the targets going forward. So thank you very much for that. So we're going to change our focus now to data centers. And so I'd like to ask Darrin Geldert to speak about that.
Good afternoon, everyone. I'm really happy to talk to you today. As Mike introduced, I'm a planning manager at Loudoun Water, and I'm going to talk a bit about Loudoun Water's reclaimed water system and how that integrates for us in the heart of Data Center Alley. If you haven't heard that term Data Center Alley, that kind of comes from the fact that right now Loudoun County has developed the largest concentration of data centers in the world. It's said sometimes that 70% of the world's internet traffic stops in Loudoun County for a while. And this growth has really been amazing, but it's really part of our larger system as a water, wastewater, reclaimed water utility. So I'm going to focus in on kind of how those data centers integrate with our system, how our reclaim system works with that. But just want to note first that Loudoun Water has a broad mission to manage our resources, to provide for our customers, and we really try and work on that through a collaborative effort to provide for all of our customers and really for the region. And doing something like this, talking to the region, is really a big part of what we like to do. But I want to give you a little context on who Loudoun Water is, and as a utility planner, kind of what I do. Loudoun Water is really fun and challenging, and I'll just show you a little bit of why that is. We serve basically the eastern third of Loudoun County, and we have a water system, a wastewater system, and a reclaimed or reuse water system. We have our own treatment plants, and we have wholesale treatment. So there's just a lot going on. And if you look at the growth in our system, just in population over the past 30 years, we're growing as fast as anyone and probably faster than most places. We've doubled in size multiple times. So that growth really required Loudoun Water and a lot of people before me to develop a multifaceted approach to deal with this. And that's with the water demands, that's with the wastewater demands, that's all aspects of this. And so today I'm going to talk a little bit more about kind of that latest aspect of this growth, and really kind of incredible growth here too, the data centers that we're seeing, and how our reuse system particular helps us deal with that. So if you look at Loudoun County, and this is our same service area here, you see all these stars on this map, and these are the kind of general locations of all the data centers that we know about. So right now, the county says there's over 30 million square feet built. The county controls this. And then there's about 15 million, maybe more square feet in development. It's a lot. As a planner, this is tricky because a piece of land may be designated or available to be built as a data center. That's something the county controls through the zoning process, but we don't really know if it's going to be air cooled or water cooled, that's potable water, or cooled in our reclaim system. So it's kind of a trick to try and manage and try and guess, estimate, project where all this growth is going to occur and how much we're going to get. But years ago, we developed this reclaimed water service area. It really started in 2015, and that kind of heavy purple line you see on the map, that's the boundary that we can serve effectively through the pumps and through the distribution system that we have now. That's the area where we can maintain pressure and give them level of service that they're going to require. And in fact, a lot of the big users, the big corporate users of or corporate data center providers, they have their own emphasis on sustainability and efficiency, and they want to come here and use our reclaim system. So it becomes kind of a win-win because they want to be here, even though the land is now getting pretty pricey. But we also like to supply them because there's some advantages to us in using the reclaim system. These new facilities are large. They keep getting bigger, and they kind of what they call hyperscaling now. And some of these campuses use a lot of energy. It was really interesting to hear the solar challenges that are out there. So we track our flows, and we've tracked our reclaim system through the years. And this is just kind of the average day flow. And I'll just point this out just to kind of show you can see a slow, steady growth there. And you can also see definitely there's a huge summertime peak, as you'd expect. The reclaimed water is generally used for cooling. We actually sized this, though, based on our max day. And this is what we contract with the data centers, or all our users kind of are based on a max day use. And again, we've seen kind of a steady growth in that use. This is how we size our facilities. This is really critical for us. And this is actually a little different than our potable water system. The peaks occur at slightly different times. It's also been a little challenge for our wastewater treatment plant operators because they weren't at the beginning, they weren't really used to dealing with a pressurized delivery system. So there's a lot of things to learn as you develop a reclaimed water system. And we actually also track our peak hour flow because that's really important for our operational staff and for understanding how much we need to provide at any particular time. If you look at that max day, you can see that there's been a slow, steady growth, or rapid growth, really, over the past 5 years. We moved from roughly that 2 MGD on the left to just over 3 on the right, meaning we're adding 250,000 gallons per day of demand in that reclaim system every year. This is significant growth. If you think of it as a percentage, we've added, 60%, something like that, over this time. So using the reclaimed water, though, really gives us a couple of different aspects as it relates to the rest of our system. So if you look at just our total water demand, there's back in 2017, the reclaim system was kind of able to supply about 5-6% of our total system demand. If you look in 2023, you can see that we're up to, on those max days, our reclaim system is providing 10 to 12% of our demand. That's a really significant amount of demand that's being supplied through our reclaim system. This kind of saves on our potable water withdrawals. This saves on us building capacity on the potable distribution side. It's been very advantageous on that part of our system. But I would also say, and I think our wastewater plant people would really say, The real advantage of reclaimed has been on the wastewater side. As you think about Loudoun Water and where we are, our Broad Run Water Reclamation Facility, or BWWRF, shown there as the star in Loudoun County, we're located right in Ashburn, right in the middle of the suburbs, basically. We are upstream. We discharge to the Broad Run to the Potomac, and we are actually upstream of the major drinking water intakes on the Potomac that serve the entire metro DC region. Of course, we're also in the Chesapeake Bay. So when this plant was built, and it was built just in 2008, we just celebrated our 16th anniversary. It's a young plant, it's relatively new, but we're discharging in an area that required a really strict permit. The effluent requirements, how much we had to clean the water is really critical because of where we're located, and it's become part of our mission, and it's really led to some visionary plans to providing for this growth and providing for dealing with that wastewater. We, for years, could send most of our wastewater down to DC, down the Potomac Interceptor. It went all the way down to Blue Plains, down to DC. However, since 2020 or so, 100% of our growth in our system is going to our plant. So this has really helped us, really required us to deal with some special things related to this. Just a second. So I'm not a treatment plant person per se, but I'm going to go into it a little bit because there's some really unique things about our treatment plant when it was built in 2008. So I'm going to ask you to just kind of zoom in right to the middle of your screen there, and there's a MBR. What that is a membrane bioreactor. So when this plant was built in 2008, it was actually the largest plant in the world that was a membrane bioreactor. And what those membranes do, they're very, very fine fibers, and they help us treat the water to a very high degree. When the water comes out of that MBR, it's quite clean. In fact, it basically meets distribution standards for reclaimed water. So we are able to siphon off the water then and send it to our reclaim system before we kind of finish, or before we polish the water, before it becomes final effluent. We're able to save the granular activated carbon, able to save the UV, and instead distribute it to our users. When this was first envisioned, I think it was mostly an irrigation system, we thought. However, it's turned out to be, now it's mostly going to cool data centers. Over 90% of the water goes to those data centers. So compared to maybe a bunch of existing treatment plants, we were fortunate. We were kind of ahead of the game thinking about this, that we could do this. So we don't have to add facilities. We didn't have to add something new in order to develop.
2-minute warning, Scott.
So we were basically, we're able to do this without a lot of effort. And this was an advantageous thing for us, even though we have this really strict effluent requirement. So there's a lot of pieces to this. By pulling off this water, we're able to save water, not send it to the effluent. This has delayed our infrastructure growth. So this was really a driver for us, this nutrient management. So a little bit of permit talk. We're currently an 11 MGD plant, and we have an allocation to send a certain number of pounds to the Chesapeake Bay, pounds of nitrogen, pounds of phosphorus. That's equivalent to a concentration, which is currently at about a 4 in nitrogen and a 0.1 in phosphorus. We're currently in the process of expanding our plant to a 16.5 MGD plant. That will require us to treat to an even lower milligrams per liter because that pound allocation to the bay isn't changing. Right now, there is no mechanism to update or change that allocation we got when the plant was first built. But we're actually in design right now to move to a 22 or perhaps 30 MGD plant, and the campus itself is envisioned to eventually go up to 40. This would bring us to treatment levels or concentrations that are incredibly low. I was told by our treatment plant people that right now, state-of-the-art treatment in Virginia is a TN of 3 and a phosphorus of 0.18. So we're already at or below this percentage. We're already treating to state of the art or even better. So this is going to be a real challenge for us as we move forward. So I'll just kind of wrap up with a little look to the future. We know that data centers are a unique feature of our service area, and they're going to continue to be. So we're actually starting to see redevelopment and conversions. Some of those are moving toward the reclaimed water system for their own corporate goals. And we're starting to see some properties we originally didn't really expect would change, but they are now changing and becoming data centers. We are expanding the capacity with our plant upgrades to help expand the capacity of the reclaim system, so we can do this even more. And that's going to challenge us as we move forward with all our permit renewals and modifications. And with that, I just wanted to thank the Loudoun Water team, because there's really a lot of great people here who I lean on every day. I'm just a piece of this, and I really have to give tons of credit to the people who came before me and all the people I work with. And I really thank you for all your time and interest, and looking forward to some questions.
Okay, well, thank you very much, Darrin. That was perfectly on time there. And I just want to say that's the first time I ever heard of data center alley. I think you've moved that term into the discourse here. Certainly appreciate your detailed description of the reclaimed water service area. First time I saw that so described, and connecting that to the data center is very interesting. And slide 4, I think, is going to be well used to show the difference between air-cooled, water-cooled, and reclaimed-cooled data centers in Loudoun. And certainly we at ICPRB will be following your reclaim capacity expansion and plant upgrades in the future. So thank you very much. But I'd like to right now thank our entire panel for their presentations. Excellent work. And we now move to our question and answer session, that will be moderated by Dr. Carlington Wallace, the Associate Director of Water Resources at ICPRB. And so, Dr. Wallace, please take it away.
Thanks, Mike. There's a lot of questions in the chat. I want to start with Darrin. So there are a couple of questions that is referencing reclaimed water, and it's can you speak on that a little bit more? The question is really asking, is the reclaimed system a completely closed loop, or is it consumed to some extent by the data center cooling? And in extension, a follow-up question to that is, is the reclaimed water sent to data centers return for treatment, or is it discharged from the center into local waterways? So that's a loaded,
Yeah, I can try and do that. So I'll just start with, every data center has its own unique cooling systems, and what I know of them, they're all a little bit different. But in general, yes, reclaimed water, we send to them. Most of them use that as evaporative cooling. So some of that is definitely evaporated to the atmosphere. After they've run through their cooling cycles a few times, that is then returned to our wastewater treatment plant. There is no discharge to waterways or other things. It comes back to the head of our plant and goes back through the treatment process. But they all seem to have slightly different cooling technologies. It's probably all proprietary. We don't really get into how they run those things, but it's generally, yes, I could say it's closed loop in that essence.
Okay, I see. And another question for you. This is also a two-parter. What percentage of data center water usage is reclaimed versus potable water? And Julie wanted to know, how much has the potable water usage increased over the period 2019 to 2023?
So last year, the reclaimed water demand and the potable water demand were very much similar. On an annual basis, they were both using in that 2 MGD range. In the summertime, they were both using in the range of 4 million gallons a day. There's a bit of variety in there, but they were essentially the same. They had caught up to one another. In terms of how much growth have we seen in the potable water system, it's definitely grown. For years, the potable demand for data centers was well below our reclaimed, and then last year it basically caught up. So we have definitely seen growth in that. I don't have the numbers at my fingertips, but I would say it's probably doubled in the past 4 years or so.
Mm-hmm. Okay.
I think that.
Thank you.
Yeah.
The next couple of questions are open to Scott and Michael. So either or both of you can address these questions. The first one is from Claire Buchanan. How much interest is there in solar panels over parking lots? And Teresa had a follow-up question to that. Is there a risk to vehicles if solar were to be built in parking lots?
I'll defer to
take
Scott.
a run at that first. So it's a question of economics. It's quite frankly just a lot cheaper to take farmland out of production and put solar energy there in terms of a cost per megawatt of energy than it is to put solar on top of an existing parking lot, or frankly on top of existing roofs. So the economics are driving the industry to take farmland and forests out of production. So that begs the question as to whether or not we can change the economics through public policy or by regulation, make sure that it's not inappropriately inexpensive to take out virgin land because you are ignoring water quality regulations, and it's cheaper to ignore water quality regulations.
Totally agree.
Thank you. Yeah, another question in the chat. Can one of Scott or Michael speak to the expectations of solar generating power that I think Michael, you presented that earlier, versus power needs of data centers projected over the same time?
Yeah, so maybe Scott can answer better because DEQ we're not the Department of Energy, so we don't do any projections of needs. We just simply permit applications when we're presented with them.
So I'll take a stab at that. So my friend Renee appropriately observed that what we thought in 2016 was going to be Virginia's energy demand is quite different from we now are projecting Virginia's energy demand. So rooftop solar could not realistically provide 30% of what we are projecting are Virginia's energy needs. And you could say the same thing about parking lot solar, if you will. The critical question really is, are we going to use nuclear and are we going to use natural gas to keep those data centers running when the sun's not shining? If we don't use natural gas, then we're going to need an awful lot of battery capacity. That means we're going to need a lot more utility scale solar to charge those batteries. If we don't have small modular reactors, then we're going to need even more land and even more battery systems. So, there's a real public policy trade-off here. Are you willing to put up with the emissions from burning natural gas, or are you willing to take a few 100,000 more acres of land out of production?
All right. Thank you. Another question for Darrin. Data centers seem to be a very hot topic. And this one is from Sherry Schultz. And she wants to know, do you have an estimate of the land area currently occupied by data center?
No, I don't have those numbers at my fingertips. I'm not sure we've actually ever looked specifically at land area. So no, I'm not sure.
Okay.
The county may have that, but we do not.
Okay. All right. Another question. I believe this question can be open to all three presenters, and it's about contaminants. The question says, aside from nutrients and sediment, are there any contaminants that are that come from data centers, such as toxic contaminants like PFAS and so on, other contaminants? Have there any, let me rephrase it. Have there been any a study to identify potential contaminants coming from any of these sites?
I'll defer to Darrin maybe first, or
I'm not sure. Within our reclaim system, all of those sites are subject to our pretreatment system, regulations. So we do monitor that. That's probably a question more for our wastewater treatment plant people, but I'm not aware of anything in ongoing or particular that's an issue with those. Any air conditioning, any cooling center blowdowns, any of that runoff we get from that, it's a little bit higher in just dissolved solids or TSS, but other than that, I'm not sure of any specific chemical issues or problems that we get. It would only be if they go through some sort of type of cleaning process of those facilities, that then potentially they could send something out that we wouldn't want to deal with at our treatment plant, because our treatment plant is largely biological. We really don't want any kind of chemicals getting in there that we don't expect, because that could kill off the biology and make the plant very difficult to run. So we haven't really had that problem, and we watch for that pretty carefully.
Now, I'll add to that DEQ does issue permits for these wastewater facilities, and so they do have a strict list of allowable discharges for a multitude of constituents, and that Loudoun Water tests for all the time. There's no difference between a cooling system for a data center or a cooling system for a commercial office building, for example, or a warehouse, and they all use cooling water. DEQ does have some general permits that allow discharge of cooling water. It's not used very often because the parameters are very strict. In some of them, like copper, they're even stricter for discharging to a natural body of water than in your drinking water, because water treatment facilities use copper, for example, to treat algae in their piping systems at a level that's not acceptable until it's treated to be discharged into a stream. So it's not a simple answer, but that's why most people do discharge these to the sewage systems. So
at the risk of answering a question that wasn't quite asked, solar panels are designed to last 20 or 30 years. So in 30 or 40 years, we're going to have tens of millions of solar panels in Virginia that are at that point obsolescent. And the question is, where are they going to go? So that'll be an interesting solid waste challenge at some point.
Or recycling opportunity.
Or recycling, even better. Ideally, recycling opportunity.
And there are companies that are starting to recycle them. The demand hasn't been very significant yet, but but you are right. They, a typical panel 25 years later is about 80% productive. I mean, it depends on the economics. I know there are some utility systems that have replaced them more frequently than that already because the newer panels are so much more efficient. So it's an economic issue, but there should be an amazing opportunity for recycling.
So I think we're at time, but I want to get in one final question. I know there are a lot of questions still coming in. So the contacts for our presenters will be made available for, if you have questions, you can send them to us and we will divert them to the proper channels and get back to you, if your questions weren't answered today. But the one final question, we know we talk a lot about water quality and so on, especially temperature, and water quantity is also a concern. And Ken Langfair, I hope I pronounced his name properly. He had a question. He wanted to know how much water would a 300 megawatt data center need to evaporate for cooling?
So I'll have to say that's part of the difficulty of being a utility planner. When we see these sites coming in, we really don't know. And it's really up to the owner of that facility to figure out how much water they may use. Some of those come in as air-cooled facilities, and they use, in essence, very little water. It's as much as or probably less than some office buildings that would be similar sized. There are others that use significantly more. So to try and put a number on that, I really don't want to. It's very difficult to estimate.
Right, thank you. So, like I said, the questions keep rolling in, but we are at time, and out of respect for the time of our presenters, we're going to end the Q&A session here, but we'll make note of all the questions that weren't answered and try to get the answers out to you in a timely manner. So with that, I would like to thank everyone for joining us today. A special thank you to our moderator, Michael Nauda-Lilly, and to our panelists for taking the time out of their busy schedule to share with us today. This webinar is being held as part of a series. We held our last webinar back in January of this year when we discussed agricultural impacts and on water quality and funding opportunities to mitigate those impacts. And today we discussed, water resources impact of data center and solar field. So we do, welcome your ideas and your input for future topics. And so I know the topic we covered today is a hot topic in the region, and therefore I'd like to share our PASA and some additional resources. There are a couple of ongoing discussions. The York River and Small Coastal Basin Roundtable is hosting a lunchtime webinar on data centers later in May. We'll put the link for that in the chat so you can, you can see what's going on over there as well. And also the Chesapeake Research Consortium Roundtable last month, they had a webinar on the topic of solar situation, the state of science and industry. We put both of those links in the chat, and you can hop over there and check those out as well. And again, big thank you to everyone who joined us today. And this webinar, like we said, is being recorded and will be made available on our YouTube page. Thanks again, everyone.
Thank you, everyone.
Thank you.
Yep. Bye-bye.
Bye-bye.